he was in 8th grade and he's coming to 9th. So initial 2 months he was in level 2, and then now he's all set to get along with you guys in the level 3, and he'll start his preparation for SAT with all of us. Yeah. All right, and we have Srivatsa on the call. He's the online student, same as Pranit. They both were part of the same group, and they were in level 2. Both were in 8th grade. Now they're in 9th. So, welcome to the community of high schoolers. Yeah. Okay. So, Srivatsa and Pranit, you guys have not heard me speak yesterday. So, since this is your first class, so I'll just let you guys know what we will do just to make sure that everybody's plan for SAT is taken care. So we have Isha in the class who's been giving SAT, and she has less time. So she has given me certain topics that she would want us to learn first. So even if that might have come for you guys a little later, but you will end up learning ahead of schedule. But net, your syllabus for SAT remains the same. Those 13 chapters is what you have to master to get your best possible score. Yeah. So you guys will be learning maybe chapter 11, 12, 10 ahead of 1, 2, 3, 4. So we are jumbling the numbers. I mean, we are looking at the numbers in a jumbled way, but don't worry about it. Concepts will remain as concepts, and make sure that we learn the concepts like child, so that we remember that for good enough period of time. Okay. All right. So, anybody has any question? Srivatsa, Pranit, Dhanushri, Isha, Atharv, anybody? And it's okay to ask questions. Okay, even if dad is sitting behind, that's fine. You can ask questions. Yeah. Yeah. All right. Okay. So we'll start with chapter, or I will not call it chapter. This is unit 11. And when I say unit 11, there is a mapping to the unit number. If you go to Khan Academy, I believe everybody has gone to Khan Academy some other point in time. Go to Khan Academy, search for Digital SAT Prep. There is a complete section for that. And when you click on that one, that gets you to that 13 chapters that I was talking about. So in that list of 13 chapters, this is the 11th chapter, which is called Advanced Maths. What is that, Isha? Do you remember?
Data analysis.
Data analytics, advanced maths and data analytics. That's what it is, right? So basically, it's part of data analytics, and it teaches some of the advanced concepts that you may or may not have learned before. Again, let's start. You can hear me, okay, Sivatsa? I'll keep checking with you, okay? Because you are the one who is farthest from me. Yeah. All right. So, so in this chapter, or in this unit, we are starting with the 3 topics that I had messaged you guys. If you remember, what was that? Ratio, percentage, rates, ratio, proportion, rates, then percentages. This is what we are starting with. And again, most of the things you guys would know, but let's see what new we are learning today. Okay. So, and then we have unit conversion and some trick questions. So Isha has some trick questions that she will share with us, and we'll try solving that in the class. Okay, so we'll try skimming through some of the topics that could be easier. So let's do a quick check. Ratio, proportion and rates. Do you all understand that conceptually, including Srivatsa? Everybody understands that? And it's a very relatable topic. Meaning we use that in our day-to-day life. You'll say, okay, I'm going to bake, and this is the proportion in which I have to add flour and milk. That we have talked about thousands of times. Yeah, I believe everybody has done baking at some point in time. Yeah, have you? Yeah, okay. Good. So now, so this is something that we have heard about. Let's say I'm planning to construct a small wall here. So when you construct a wall, you say, okay, you have to mix the sand and the cement in a certain proportion. If you are adding more cement, you would need more sand. If you are using less cement, you will need less sand. So there's some ratio, some proportion that we always talk about. Okay. Srivatsa, are you with me so far?
Yeah.
Okay. So let's do a quick recap of what is a ratio. Ratio means something against something else. Let's say A is the number of apples and B is the number of oranges in a basket. Ratio A to B. What would that mean? Anybody? Very simple ways. I don't ask tough questions. These are easy questions. Ratio.
Is it about compound?
Yes. Now I'm saying ratio A to B. If I say that, how would you represent that in a sentence, in a mathematical expression, whatever you call it? How would you represent that? Ratio A is to B. You guys are overthinking. Ratio of A over B. And I said A is the number of apples and B is the number of oranges. So here we are talking about one part of the bag is apple, second part of the bag is oranges. So this is part to part ratio, A to B ratio, meaning ratio of A against B. If you say B to A ratio, you will say B by A. Yeah? This is part to part. One part is compared against the other part. That is why it is called part to part. There is one more type of ratio. What is that? Anybody remembers? Part to whole. Say it loud. Don't worry, it's okay. It's okay to make mistakes. Okay? Part to whole. Meaning, if somebody says, what is the total number of fruits that we have in the basket? Yeah? What is part to whole here? Apple to the total number of fruits. This is one part to whole. Apple against the total count of fruits in the basket. Or oranges against the total count of fruits in the basket. This is called part to whole. Part to part, when you are looking at two elements in your in your scheme of things, whatever you have, and then you compare them against each other, like A by B or B by A, that is part to part. You are comparing one part against other part, that is why it is called part to part. When you compare one thing against the entire thing in the basket or entire thing in the mix, let's say you have 10 cricket players or 20 football players in a group of 30 kids. Football against cricket will be 10 by 20, or cricket against football will be 20 by 10. But if you are saying cricket against total number of players, that is when it becomes part to whole, 10 by 30, or football as a whole, football to whole will be 20 by 30, whatever it is. Yeah. So this is part to whole, part to part. This is the ratio part of it. Any doubt so far? See what's up? Kids here? Anybody? No question? No doubt? Okay. Now, so in very simple terms, whenever you come across a ratio of A to B, that's the kind of a very normal scenario, right? Let's say I earn $1,000 and I spend $800. People will say, what is the ratio between your earning and spending? This much I earn, this much I spend. Earning versus spending, that is my ratio. This is a very normal scenario that we all keep hearing about, keep coming across. And any math that we do, eventually it has some bearing with what we do in our day-to-day life. So there is no math that I'll teach you guys which you will never come across, for sure. Okay? So this is the ratio part. Now, what is proportion? I said proportion is, so Sivat sir, you are fine with the ratio part that we've discussed so far, correct?
Yeah, I understand.
Okay. And then if you talk about proportion, I gave a very crude example saying, do you guys want me to close the shutter? That might make it a little cooler. It's okay? Oh. Okay. So if you look at proportion, I was giving an example of baking, right? Where we say flour and sugar has to be mixed in a certain proportion. Flour and milk has to be mixed in a certain proportion. So, what is the difference between ratio and proportion? Can anybody tell me? And again, I don't ask him tough questions. These are easy ones. Okay. So don't overthink. Keep it simple.
Proportion is like one increases, the other should also increase.
Yes. That is one definition. Any other attempt? Srivatsav, you can also try. What is the difference between ratio and proportion? They sound very similar to me. Yeah, it does. Okay. Any guesses? It's okay. It's okay. Make a mistake and feel happy about it. It's fine.
It's like a comparison between two numbers in a percentage or like in like percentage form or something.
Sounds familiar to me. Yeah. So let me not keep it like a secret with you guys. So ratio is proportion is nothing but it gives you a scenario where you prove your ratio to be right. So when the ratios are equal, that is when it becomes proportion. That is when it is called proportion. Now look at this. I said I want to bake. I'm making this smaller cake. Okay? And then I plan to make the cake bigger because I changed my mind and I wanted to invite a lot of people. And just for the sake of making it up, this one is 4 times the size of this guy. Okay? Okay? So this one you can feed maybe 4 people. This one you can feed 16 people maybe. Okay? So this is 4 times the size of this guy. Now, what you know is, whenever I'm making cake, my ratio between flour and let's say sugar has to be 1:8. Meaning every single teaspoon of sugar that you will add, you have to have 8 teaspoons of flour. So let's say for this one, if you are giving 1 teaspoon of sugar and 8 teaspoons of flour, here what will you do? You will multiply everything by 4. So this is 4 and this will become 32. Here what is the ratio between sugar to flour? 1/8. Here what is the ratio between sugar to flour? Same thing, 1/8. Sorry, this becomes 1/8. Yeah. So proportion is a way to make two ratios same. So you said my proportion of this relationship here is a ratio 1/8. Proportion just helps you make sure that ratio remains the same. Nothing different. Yeah? Am I making sense so far?
Yeah.
I'll repeat myself. So when we talk about ratio, we compare one quantity against other quantity. When we say proportion, we say, okay, my ratio will remain the same no matter how small or big quantity we are talking about. So it just helps you keep the ratio same. That's it. No difference. Yeah? So somebody is thinking or not thinking. Are you able to relate to what I'm saying? Everybody? Dhanushri, Srivatsav, Atharv, Isha, everybody? Yeah? Okay. So just to summarize before I move on, 2 things we have learned. One is ratio. Ratio is nothing but comparing 2 things. I say ratio of A versus B. Let's say if I say Atharv's age versus my age ratio, it will not be 1/4, it will be 1/3 maybe. Yeah? It will be, if you are 13, we can make out how much I am. Right? I'm much more than that, but yeah, it's not 1/4. For that I have to cross 40. Cross 50 actually. Alright. So ratio is just a comparison. As a fraction. That's what you can do. You can, if you write something as a fraction, you can convert that to decimal, you can convert that to percentage, whatever you call it, you can do that. Yeah? We'll probably touch upon that also quickly. But ratio is nothing but comparing 2 numbers, and you can represent that as a fraction, as a decimal, as a percentage, whatever you call it. Okay? You can say, okay, Atharv's age is maybe 30% of my age. Yeah? See, Pranit's age is probably 39% of my age. Yeah? So that ratio is helping you convert that to percentage. You can convert that to fraction, and if you have a fraction, you can convert that to decimal also whenever you feel like. So these are different ways. Then we learned about proportion. Proportions sound similar. It's pretty much similar. Only difference between proportion and ratio is that proportion just helps you ascertain that you're talking about same ratio. Smaller cake, same ratio. Bigger cake, same ratio. Your ratio remains the same. That is what is proportion. Alright, done? Okay. Now let's look at rate. Srivatsava, are you with me so far?
Yeah.
Okay. And stop me guys if I'm lagging too much, okay? I'm just trying to make sure that I'm just not rushing through the concepts and just assuming that everybody is understood, okay? Alright. Now, rate. What is the rate? Again, think of practical examples, okay? Don't become so mathematical. What is the rate?
Percentage.
Make it more practical. Percentage again is a mathematical term. Not everybody would understand that. Yeah. So if you have to define rate, you guys came from home to the class. How much time did you take? 20 minutes? 25 minutes? More? 40 minutes? You guys living that far? Okay. So let's say you took 40 minutes. At what speed did you come? Wherever it was like a freeway, you probably drove at 70 miles per hour. What is that 70 miles per hour? A rate. So, one unit being measured against another unit, that is what is called rate. For a more practical purposes, most of the times we talk about rate against time. I mean, when you are measuring distance, speed, whatnot. But if you are measuring your shopping experience, you'll say, okay, I bought 5 dresses for $100 or $150. So $30 per dress is my average spend. Yeah. Or you will say, you went to Walmart, you bought potatoes. I don't know, you guys don't, but still. So you bought potatoes and you'll say, okay, the price, how is the price written there? They say $5 per pound, $2 per pound. That is how they represent it. That is nothing but the representation of the rate. You are measuring one unit, you are measuring weight, pound. You are saying dollar per pound. That is the rate. Distance per hour is a speed. So when you are measuring one unit against another unit, that is when you come across something called rate. Okay? Everybody with me so far? Anusri? Athar, everybody? Yeah. And I keep on making eye contact with you guys so that when we make that eye contact, that tells me that am I reaching you guys or not. So yeah. Everybody clear? Yeah, so far? Srivatsava, you are also clear?
Yeah.
And Srivatsava, you might want to keep your video on because you are not being recorded. Recording is all happening on the iPad. So yeah, we are good. Okay? Alright. Now, we looked at ratio, rate and proportion conceptually. Now, what I would want, we'll do some sums, but not for ratio, rates and proportion. These are the easier concepts. But if you guys have some questions related to this, please feel free to ask, and we can try solving it here. Following the same method, like I always keep bragging about. Yeah? Yeah? Alright. So this is the ratio, rate and proportion. Now, a relatable thing is percentage. That's what we wanted to talk about, right? But before we go to percentage, I wanted to play with math a little bit. Do you guys do tic-tac-toe? Yeah? Do. Everybody has done tic-tac-toe, right? You guys enjoy it? Math is also one form of tic-tac-toe. Okay? If I have to divide, let's say something by this, it's easy. You all know how you do division, right? You will say, okay, fine. 20 times 5 is 100. What if somebody tricks you and says, where did I keep it? Okay. So if somebody tricks you and say, okay, now you guys are having fun, divide 218 or now divide this by this. Yes, sir? There are two options that you have. Either you go back to the old school, memorize the table of 18, then you do it. Yep. I'm not trying to make you guys think of anything negative, okay? I'm just telling you what is the option. If I'm in your situation, this is what I'll do. There are two options that I have. I have to memorize the table of 18, or else do that calculation in a dirty way, which will take a lot of time from me. And this is where tic-tac-toe plays a very, very important role. You guys all would have heard about factorization, right? Factorization. How do you factorize or break a number into smaller numbers? Or into a multiple of smaller numbers? Can you guys help me do that? Can I say 18 I can write as 6 into 3? I will see, okay. And do you know if I can divide this by 3? Let me see. 3 7 are 21, 2 3 8 are 24. I can write this as this. This makes my life a little easier actually. Now I can do tic-tac-toe. So I have 1 in the denominator, 1 in the numerator. I can knock them off. It's a much simpler maths to deal with. If I want to make it even simpler, I will, let's see, if I can divide, multiply this as, write this as multiple of 6. 6 1 is 6, 6 3 is 18. So I can write this 13 to 6. That is 78. I did not do any division. I did not deal with any big number. It made my life a little easier. No, it's okay. Tell me if there is something that you have any question about. A third? Yeah, sure. No, it's okay. Just feel comfortable, okay? If you have to ask something, please feel free to ask. Now, I'll tell you why. Why this is important? Because you don't want to deal with larger calculations always. That is not fun. You might end up dealing with them, but then do you really want to do that? You don't. Because that takes a lot of time, and that is where some tricks will help you. Now, if I give you a number and ask you, is it divisible by 3? Can you tell me in 5 seconds? Is it divisible by 3?
Yeah.
How?
Because 21 is 210 is like divisible by 3 and plus 3.
Okay?
You add all the numbers and
You are getting there. That's what I wanted to know. Because see, what you did, I thought that could be right. What if I trick you and say, okay, 1 4 9 3 2 6, and tell me if it is divisible by 3? No, see, these are the fun part of math. That's what I'm trying to make it more interesting for you guys. What will you do? If it is about 3 and 9, if you have to find out any number is divisible by 3 or 9, just add them. Let's see if I add them all, what is the value? 6 plus 2, 8 plus 3, 11 plus 9, 20 plus 24, 24 plus 1, 25. 25 by 3. 25 is not divisible by 3. This number will not be divisible by 3. Same thing applies for 9 also. Only 3 and 9, remember this. Okay? Only 3 and 9. Will this number be, if let's say somebody gives you 9 0 1 4 5 2 7 8, is it divisible by 9? I can do that in 7 seconds. I'll just add them. 15 plus 2 17 plus 5 22 plus 4 26 27 plus 9 36. 36 is divisible by 9? Yes, it is. And then I can play with it. Now you tell me, how do I break it down? You can divide this by 9, right? You can do that. And I'm not teaching you guys that right now. We'll probably when we do more sums, we'll practice that. Okay. So remember this: 3 and 5, 3 and 9. It's very easy to find. Just add them up. If the sum is divisible by that 3 or 9, it is divisible by 3 or 9. Okay. Similarly, if some number is divisible by 10 or not, it's easy to find out, right? If I ask you, is it divisible by 10? No, right? Last digit has to be a 0 at least. Any number divisible by 5, you will look at the last digit. If it's 0 or 5, it is. Yeah. So 3, 9, 5, 0, 10, 2, we will know, right? Same thing for 4. If I give you a number, I'm just doing some prep work for the percentage thing, okay? So if I give you some number 126, is it divisible by 4? How will you find it out? See what's up? If I'm giving you 126 and asking you if it is divisible by 4, how will you find it out? You'll always look at last two digits. 100, any 100, yeah? Any 100, be it 100 or be it 1,000,100, that will be divisible by 4 for sure. My only contention could come from these two digits. If my last two digits are divisible by 4, meaning if it's 36, it can never be divided by 4. So this number is not divisible by 4. I mean, you can get decimals, you can't get a whole number. Yeah? So if I give you ever, is this divisible by 4? Don't break your head, only look at last two digits. If you can divide this by 4, you can say yes. And then if somebody is asking for the answer, do it and find the answer. That's okay. So this is just the prep work before we get to percentage. Now comes percentage. Percent. Everybody has heard about cricket? Everybody knows what is a century? Yeah? So cent is nothing but a shorter version of century. Okay? Percent. Break it into two words, per and cent. Per hour, per minute, per day. Yeah? Yeah? Per, we know, right? If I have to say, okay, what is the speed? You'll say, okay, 70 miles per hour. Meaning, if you spend 1 hour, you are going to cover 70 miles. Yeah? So, same way, percent. Always read this with a pause in between. Percent. Per 100. So that is where the whole thing lies. There is no math involved here. If I say 20%, read this like English. 20 per 100. 20%. Cent is century, 100. So if there is 100, I am talking about 20. That is what it is, 20%. Okay? Now let's say you guys got, I would not know who gets how much pocket money, but let's say you guys got $50 as a pocket money for 1 month, okay? And I say, okay, give me 50% of your pocket money. We'll do some, some fun activity on the weekend. Now, let's say Athar got 50, Pranit got, let's say, 40, Isha got 70, let's say Dhanushri got 60, and Srivatsav got 30. So I'm not going to get same amount of money from each one of you. I'm just going to get 50% of what you got as your pocket money. Okay, I'm getting wet now, but that's okay. So when I say percent, 50%, meaning 50 of 50 per 100. So if anybody got 100, that person only will give me 50. Otherwise, he will give me the money in the same proportion. That's what it means. So now, let's look at how this is the English part. We have not started maths yet. So I said, any person, let's say 30%. So 30%. Or I can always think of this as 30 per 100. Meaning again, if you speak, or if you, let's say, if you say the sentence couple of times, 30% or 30 per 100, that means if I have 100, I'm talking about 30. If I have 50, how much I'm talking about? 15, yeah? And you don't have to go with your instinct. You will always look at it this way. For every 100, I'm talking about 30. If I'm saying 30%, I'm talking about for every 100, it is 30. If it is 1, then how much I'm talking about?
0.3.
I will not go there. You will find me as a teacher who doesn't like answers. I don't want to hear the answers. I want the process part of it. So 0.3 is the right answer, okay? But I'm not really interested in that. What I'm interested in is I will say, okay, if it's 100, I'm talking about 30. If it's 1, how much I'm talking about? 30 by 100. So if you tell me this, that makes me super happy. Because that ascertains that yes, you know the calculation part of it. The process part of it. Now the calculation you guys know. You guys are intelligent enough to do this calculation. I would not doubt that. Yeah? So if it's 1, I'm talking about 30 by 100. And again, there's a thought process that will go in the back of your mind. If it's 100, I'm talking about 30. So if I'm talking about 1, meaning I'm making it smaller. From 100 came to this. So I have to divide by, it's like this guy goes downward, moves this way. Yeah? You can imagine this like a equal to sign. You're saying, okay, if it's 1, it becomes 30 by 10. So if it's 15, it's like this. If one pound of tomato, if it comes for $2, if I have to buy 5 pounds, what does it mean? 5 into 2, same thing. For 100, I'm talking about 30 because it's 30%. So for 1, I'm talking about 30 by 100. If I'm talking about 15, it will be multiple of 1. Now you do your calculation. I'll not stop you guys from doing that. Okay? This, what did I do? Okay, I said 50, if it's 15. So this is giving me 30% of 15. Yeah? Now you look at this math a little differently. Okay? What do you have? I have 30%. 30%, 30 per 100. That's what it is. Okay? So if you read this, 30% of 15. This is not math, this is English. Yeah? 30 per, see, what do you write? 70 miles per hour. Yeah? Here, miles per. This stands for per. 30%, 100 of 15. That is how I read this. So tomorrow, I will not even worry about all this circus that you are doing here. I will read this in the English. And let's say somebody says, find out 50% of your pocket money for the month of May. Let's say a third got 100. Isha got 120. Okay, I'm just taking 2 examples for now. Putting pressure on your daddy, okay? Now, I'm saying give me 30% of that. So author says 30% of whatever I have is this. Okay? And then he does tic-tac-toe. Because I will force you guys to do tic-tac-toe. That makes your life a little easier. What I'm doing is I'm just breaking this into smaller multiples. That's it. Now, this is gone, this is gone. I have 30. So a third decided, okay, I have to give 30. Easy. Now Isha says, okay, 30% of what I have. 30% of whatever I have. Yeah? Then she also does the same tic-tac-toe. 3 into 10. I mean, you can keep on breaking it the way you want. Okay? 10 into 10. So 2 tens, she will knock off and she gets 36. So Athar will give me 30 and Isha will give me 36. Not by doing any math, they were just talking in English. Any percent of into is like off, yeah, something. So this should be the easiest thing for us, all of us to do in future. If somebody says, find out 9% of a given number, 9% of whatever number. So I would not expect you guys to even think twice when you have to derive a percentage of any number. That is one part of it, okay? And it is English, it is not math yet. Now, this is one part. Now somebody says, the money that I make is, I want to know what is that, how much percentage is that of other number. Okay, let's say Praneeth got $10 from somewhere, and Dhanushri got 15. Praneeth wants to know what is my percentage against Dhanushri's number. So in a way, he's trying to find out 10 is what percent of 15. Any number is what percent of another number. Look at this. This is again English, okay? Any number is what percent of second number. Just write this. This tells you the value. Any number is what percent of, or look at this way. Any number is what percent, okay? Question mark. What percent of other number, let's say, this number. And later on, you will just, we don't calculate with question mark, we calculate it into our division, right? So just put this. So, what I'm trying to say is, if you have to find out any number is what percentage of any other number, that number which you are trying to find out will be your numerator, and the number against which you are trying to find out the percentage will be your denominator, and then multiply by 100. Now you will say why. You can prove that. So let's say a number 10 is X percentage of 15. Okay? And we don't know what that X is. Yeah? Now, based on whatever we have done, let's say X percent of 15 equal to 10. That's what is the English part of it. We know that, right? I mean, if I have to find out 10% of some number, something, right? What I will do? 10% of that number. Yeah. So here we said 10 is X percent of 15. Okay? 10 is X percent of 15. So 10, Praneeth got 10, Dhanushri had 15. Praneeth wants to know, I have what percent of the value that Dhanushri has. So he doesn't know. So he said, okay, it's probably X percent. That's my variable. That's my assumption. So 10, the value I have is probably X percentage of what Dhanushri has. He just put the assumption here. Now by the English part of what we have learned is X percent of 15. What will that be? X percent of 15 will be 10. That's what he assumed, right? We are just putting that in the mathematical form. Are you with me so far, Srivatsa?
Yeah.
Okay. So we are just, see, whatever we have heard, we are just putting that in the mathematical form. X percent of a number is 10. That's what Praneeth assumed, okay? And we are just putting that in the form here. So now, again, there is some kind of a game happening here. What will you do? Whatever is the denominator goes to the to become numerator. Whatever is here comes here. When you make them cross the border, the equal to sign. So it becomes, if I keep only X this side, I move everything to the other side of equal to sign. This goes up, goes here. This one comes down, comes here. Now you do whatever you want to do. So you will know that this becomes 5 into 3 and this is 5 into 2. So let's do that So it becomes 200 by 3, which will be equal to 66.66. X is nothing but 66%. Or Praneeth has 66% of what Dhanusri had. So when it comes to percentage, there are only two things that you will do. Okay, there are only two types of sums that we do. One is finding the value of a certain percentage of a number. Okay, you have one number, find out X percentage of that. With 5%, 10%, 20%. We'll come to the sums. Okay, Isha has some sums that we want to solve today, right?
Yeah.
We'll do that. So one is the finding out certain percentage of that number, percent, 13% of a number. Okay, that's the English part of it. Second thing is when you have to find out any number is what percent of another number. You just put that number against the number for which you want to find that percentage and multiply by 100. This will be your answer. How is what we saw just now. Okay. Now let's look at, see, if I keep talking about percentage, you guys will start laughing at me because there is no new concept that we learn. Let's look at some sums and see whatever we have learned, how we can use that concept for solving it. Can you read that question for me? So, Srivatsap, so far you are fine with whatever we have discussed? Yeah. So, we have just talked about finding out a percentage of a given number. Okay. X, let's say the number is X. If I want to find 30% of that, so 30% of X, that is what my value would be. If I have one number X and I have another number Y, I want to find out X is what percent of Y, that will be X by Y into 100. These are the only two types of calculation that you will do in percentage. Let's see some questions and try finding out if whatever we have learned is helping us solve that problem or not. Okay? And yeah, can you read?
The student population at University X consists of 63% undergrad students and 33% grad students.
Okay.
If 23% of undergrad students and 42% of grad students wear contacts, what percentage of all students wear contacts?
So this is where this will come into play. Okay. So what we are doing is a practical example of this. You said something, I heard something, and I don't recall everything, right? So what I heard was 63% of undergrad students is, can you read that one more time for me?
The student population at University X consists of 63% undergrad students and 37%
37%. Okay.
grad students.
Okay. So that is first line. Say some university has this much percentage of undergrad students, which is 63, and 37% of graduate students. Okay. Okay. This is one information we got. Can we go to the second line?
If 23% of undergrad students
Okay.
and 42% of grad students
Okay.
wear contacts,
Okay.
what percentage of all students wear contacts?
Wonderful. So now, see, you read this question 3 times for me, and that made the question look easier for me. I was kind of confused when I started. Now, since I heard it a couple of times, let me repeat, and that is not for you guys, but for myself, saying our University A has 63% of students who are undergrads and 33% as graduate students. That's the first information we got. It says if 23% of undergrad students, 23% of undergrad students, I'm stressing on the words that I heard, okay? 23% of undergrad students are wearing contacts and 42% of graduate students are wearing contacts. What is the total percentage of students wearing contacts? Simple. That question is understood by everybody? Everybody, right? I can say that in layman's term that a college or university has some graduate students, some undergraduate students, and this is the split. that is given to us. And among them, 20, see, undergrad students are 63%. 23% of that is wearing contacts, and this much percentage of grad students wearing contacts. What is the total percent of students wearing contacts? The question is clear to everybody, right? Now, any guesses how you would want to approach? See, we did the reading part of it. Trust you all have that yes, I can solve it. Now we are going to A part, which is the analysis part. Yeah. How now you make your mind how you want to approach this.
Would you like figure out how many would you put would you add the percent of undergrads and grad students that are in contacts to enter it over 100%?
Yeah, that's what it will be. Ultimately, that's what it will be, right? Because it says find out the total students who are wearing contacts. So I have to get the total count of undergrad students and the total count of graduate students and add them together. Be it in form of percentage, be it in form of numbers, if I know at all. Here so far I have not heard numbers, I have only heard percentages. So I'll probably deal with percentage. Yeah? Srivatsav, have you heard the question well?
Yeah.
Okay. Now see again, we can do 50 sums. I don't want to. I want to give you guys an approach here. By reading this question, by using that magical formula I talked about yesterday, can you guys try solving it? I'm giving you another, let's say 2-3 minutes to just give me an approach. The analysis part, the end thing I will leave it for you guys. But analysis part, the A part, how are you approaching this problem is what I want to know from you. Okay, let me interrupt everybody. So, see again, this is normal human tendency, okay? Everybody started solving this. You all jumped onto this one. Nike, just do it. Yeah? I wanted you guys to take a pause because that will help you be correct and that will help you cut down on the effort that you will waste otherwise. Okay? So the analysis part, okay, that is very important. That is the brain of your problem solving ability. Okay. So now what I wanted you guys to do was this. And trust me, after that it will be very easy. Okay. See, now if you look at percent, 100%, some percentage, right? You have some undergrad percent, some students who are undergrads, some are graduate students. One thing that you would have observed is, if you add them together, this makes 100%. 63 plus 37 makes it 100%. That is one observation I want you guys to make. That okay, there is no other flavor of student that I am going to come across as part of this question. That is one. Now, whatever number, so here, when you are doing the analysis, what you do is, okay, fine. One analysis says, okay, fine. This is the only two flavor of a student that I am going to talk about. Now, 23% of this is wearing contacts, and 42% of this is wearing contacts. So your analyst should tell you that okay, if I find out 23% of this and 42% of this and add them together, that will give me the answer. Now you guys know how to find out percentage. Okay? So before you start solving it, you should make your mind that yes, first of all, there is no third flavor of student. There is undergraduate and graduate students. This makes the whole population. That is one. And now, if I get 23% of this and 42% of this and add them together, that is my answer. How? We'll do it now. Okay. So, while doing the analysis, if you get this point right by reading or noting down the points, trust me, your calculation becomes much easier. Your time taken for this will become much lesser actually. Okay? Srivatsav, are you with me? Yeah?
Yep.
Now, it's very simple. Okay, let's say the class has 100 students. Okay? What that means is 63%. So 63 students are undergraduates. Yeah? I mean, nobody has told me number. I can assume. Let's say 100 students. 63 are undergraduates and 37 are graduates. Yeah? Now, if I have to find out how many are wearing contacts who are undergraduates, so 23% of 63. This is the number of students wearing contacts in a group of 100. Yeah? I'll keep it here. Then this one 42% of 37. Yeah, this is my second number. This is the graduate students. Yeah, if I add these two together, that gives me a total count. Yeah, so we have to do some maths here. Yeah, now look at this. So basically, I can take 1 by 100 as common, which is out. Then 42 into 37 plus 23 into 63. This sum I have to do. Okay. This gives me what? Total count of students wearing contacts. This is this part, and this is this part. So this is what we are asked to do, right? If I add, do all the calculations. Let's say you might be allowed to use calculator here. Once you add them together and do the calculation, let's say this one gives you somewhere around 1/3, maybe 15, somewhere around 15. I'm just giving an approximation, okay? And this gives me maybe 14, okay? I'm not doing the calculation accurately, I'm just getting the approximate value, okay? So this gives you what? 15 plus 14, 29. What does it mean? When you do calculation, you might get 29.12 or 28.75, whatever it is. I got 29, let's say. What it means? In a group of 100 students, 29 are wearing contacts as per this. So this is what? In a 100. So this is my percentage. I will say 29%. Everybody here. So now tell me, what did you understand? Did you understand what I did first of all? Okay. Let me repeat, okay? Not because I want you guys to memorize this. I'm just telling you the approach I took. And I would want you guys to take the same approach, a similar approach. First thing is, read the question. This tells me that, okay, this is the split. 63% undergraduates, 37% graduate students. And then says 23% of undergraduate students. 23% of undergraduate students. So whatever is the count of my undergraduate students, 23% of that is wearing contacts. Similarly, 42% of my graduate students is wearing contacts. What is the total percentage or total percentage, right? That's what the question is. What is the total percentage of students wearing contacts? So by looking at this question, find a chair, sit down quietly. Your turn will come. Take a chair, sit down. Let me finish this class, okay? Alright. Find a chair, tool, settle down. Okay. So here, first thing we did was we read the question and we understood what is that is to be done. And then we said, okay, fine. 23% of 63 is one part. 42% of second thing is the other part. And if I add them together, then I'll get the answer. So we assumed, okay, since I don't have the numbers given, I can assume 100, I can assume 500, whatever I feel comfortable with. So we picked up 100. that makes my life easier, right? Because we'll pick 100 because if you find something out of 100, that is your straight percentage. You don't have to do any other calculation. So that's what we said. Okay, fine. Let's say the class has, the university has 100 students. If it is 100, how many are undergraduate? This many. How many are graduate students? This many. Now, what is 23% of this many? That's what we found here. What is 42% of this many? That is what we found here. Added them together, got the answer. So here, you have to always keep in mind that when you have a question, don't jump to Nike. Nike is a very good brand. You all like Nike shoes. Don't get to Nike first. Nike is your last step. When you complete your analysis, then you jump onto this one. Find the chair, Ishan. Just find the chair, no making noise. You guys have to be serious, okay? Find the chair, sit down. If you don't find the chair, I'll get you one. I'll get you one, okay? Yeah. Just be respectful of the class, okay? Yeah, take this chair, Ishan, sit down quietly. I'll finish in 5 minutes. Is that important? Keep quiet. Okay, so this is the part, right? That you have to analyze and decide on the approach that you want to take, and then you start doing it. It might look a little lengthy, cumbersome, but trust me, if you look at 5 sums together and then you look at the effort that you're spending by choosing one of the options, you will end up saving time. Okay? Did you have other questions also?
Yeah, but for this one, I did it using the second way you taught.
That is?
Like 10% or 15%. Is that right? Or
So if you have done some scratch work, send me a picture of that, okay? I would just take a look at it, because I always look at maths like English, okay? If I read the way it is written in the question, and if I kind of transpose that in a form, it becomes a mathematical formula, solving becomes much easier. So now, since we have done it certain way, right? Now you just don't waste too much time, but just look at relating that with a similar approach. Say, okay, fine. If I am using this approach, is it the right representation of the information I have in the question? And if you get a side answer, wonderful. Then you know whether it's right or not. If not, if you have any doubt, just take a picture of that, send it to me, of the scratch work that you have done. Okay? That would make it clear for us. Okay? And the next question, if you have, what I would request is, take a picture of that and send it to this group, okay, so that everybody gets that question. Let everybody make an attempt at that, okay. I will give some assignments to you guys anyways, but in the meantime, whatever question you guys have, keep circulating that among yourselves, so that somebody will find some interesting way. Trust me, within the student community also, somebody can find a much more interesting, simpler way than what I can do, and ultimately it's you who gets benefited. Keep quiet. That is not important till we start the class. Okay. So that's what I'm saying. Be respectful of everything that is happening around you. Okay? Yeah. Alright. So that brings us to the end of the class.